Hi, welcome to Statistics Online. I'm Naomi Lowe, and this is lecture number 1, part 1. Lecture 1 will cover branches of statistics, variable types, summarizing data with graphs and tables, distributions, and misleading graphs. Today, in part 1 of lecture 1, we will cover branches of statistics, both descriptive and inferential statistics, and we will cover variable types, both numeric and nominal, and then we will break down numeric variables into subtypes. The branches of statistics, there are two major branches. They're descriptive statistics and inferential statistics. Now, descriptive statistics works with numbers that you have collected. It works with data that you actually have. Descriptive statistics is summarizing numbers into meaningful units, summarizing and organizing those numbers. For example, in our class, you may want to know what the ages of students are. And you can take the age of every student, you take the mean or the average, and you give one number that tells us something about our class. It's summarizing information about our class. Inferential statistics, on the other hand, deal with drawing conclusions about larger groups that you don't have all the information from, making inferences from larger groups that go beyond the data that you've collected. So, for example, you might want to know how many women and men are enrolled in this class that you're taking. That would be a descriptive statistic. I could easily calculate how many, count the frequency of men, count the frequency of women, give you a number. You have all the numbers. You know exactly how many men and how many women are in the class. That's a descriptive stat. Now, an inferential question that's related to that, you may want to know how many men and how many women are enrolled in college in the country. Okay. We probably do not have the resources to go and survey every single college and find out the exact numbers of men and women, but we might be able to take a sample, a smaller part of the population, and then draw a conclusion, a good estimate of how many men and women are enrolled in colleges around the country. Okay. Another example of an inferential statistic, I could ask the question, who's smarter? Who has a higher IQ, men or women? What do you think? Well, whatever you think, if we're going to go out and do statistics to figure this out, we probably are not going to survey every single man in the world and administer an IQ test, and every single woman in the world and administer an IQ test. It'd be literally impossible. So instead, we will sample, we'll take a small group of this population we're interested in, and administer the IQ test to this small group, look for differences, and then draw conclusions about the larger group we're really interested in, all men and women, based on this small set of data for some males and females. Now, let's move on to variable types. Now, this is also called level of measurement, which you'll find out in just a little bit, because the types of variables that we have depend on how you measure them. Some variables you can measure in different ways. There are two basic types of variables, nominal and numeric. Many times nominal is also called categorical or qualitative. A nominal variable is something that does not deal with numbers. For example, ethnicity is nominal. Hair color is nominal. Now, if I asked you to get into a line in the classroom by hair color, you would have no idea, starting with which blonde or brunette, you can mix them around. There's no natural order to that. There's no numerical order. So it is a nominal variable. The same thing is true for ethnicity. Now, you could assign a number to ethnicity. You could assign 1 for Caucasian, 2 for Latin American. That doesn't mean that it is now a numeric variable just because you assign a number. That you could still move those numbers around and that you can't add them up, you can't average them, so it's a nominal categorical variable. Now, numeric variables are also called quantitative variables, and we're going to break down numeric variables into further subcategories. Numeric variables, or quantitative variables, have a couple of ways that we can define them. The first we will talk about is discrete versus continuous. Now, the difference between discrete and continuous, they're both numeric, but one discrete it has to be solid numbers, 1, 2, 3, 4, 5. Continuous, you can measure in between numbers, like 1.246 or 2.5. That's the difference between discrete and continuous. Discrete is typically a count of something. For example, the number of hairs on someone's head. That's a count. I either have 1,000,000 hairs or I have 1,000,001. I have 1,000,000, I pull one out, now it's one less than that. You don't have 1,000,000.245 hairs, so it's a discrete variable. There's no in-betweens. An example of a continuous variable is age. You might say that you're 5, or a child might say they're 6. But have you ever heard a child say, I'm 5.5 or 5 3/4? Age can be measured in between numbers. You can even go down to the second, how many seconds old you are. So it's a continuous variable. Now, all numeric variables can be defined as discrete or continuous. In addition to being able to be defined as discrete or continuous, we break up numeric variables into 3 more categories. These categories are ordinal, interval, and ratio. Now, they're also called rank order or equal interval in your textbook. Now, ordinal is a category that's a little tricky. I listed it under numeric variables, but it can fit into categorical variables in addition to numeric variables. Ordinal means there is some natural order. Okay? If I asked you to line up according to this variable, you would understand it starts at the low end and ends at the high end, and there is a natural order. But that natural order doesn't tell you about the distance between each person in that order or each place in that order. For example, if you run a race and you get first, second, third, fourth, fifth place, that would be an ordinal or rank order variable because there is a natural order. I could say line up according to the ribbon you got, first, second, third, fourth. But it doesn't tell you anything about the distance between first place and second place. Maybe the runner from first place was only half a second away from the runner in second place, or maybe they were a whole minute apart. So the distance, we don't know, even though there is an order to that rank. Now, the reason I said that ordinal is a little tricky, it can fit into categorical variables because you might have something like Olympic medals, where there isn't a number. You have gold, bronze, silver, but there is a natural order. But it gives you a little more detail than just a nominal variable that is only groups. Now, moving down to the next level of numeric variables, an interval variable is a numeric variable that not only has order, but the distance between each place in that order is equal. So knowing the first place, second place, third place, it may or may not be equal, but on an interval ratio, you know that the distance between each person is equal. Now, let's move one more step down on the variable types to ratio variable. Ratio variable is a variable that gives you equal intervals, but in addition to giving you equal intervals, it also gives you a true zero. And by true zero, I mean that if 0 is the number, it represents nothing, because 0 means it doesn't exist. Here's an example of a non-true zero. A non-true zero would be temperature. Temperature, if I say it's 0 degrees outside, that doesn't mean there's an absence of temperature. That's not a true zero. It's just a label we give for certain weather. Okay, so that's not a true zero. That would not be ratio. You'd have to move up to the next level, and that is interval. Okay. An example of a true zero is height. Okay. If I go, how tall are you? Okay. If you're 5 feet, that's a good number to put on there. 0, that means you're not there. There is no height. It doesn't exist. The 0 doesn't represent some amount of tallness. So it's a true 0. That would be a ratio variable. The second component to a ratio variable, in addition to needing a true, meaningful 0, is that this variable makes meaningful ratios. And so if you were 6 feet tall and someone else was 3 feet tall, that would mean you are twice as tall as the person who's 3 feet tall. So the ratio makes sense. Where if it's 100 degrees, that doesn't mean it's twice as hot as 50 degrees. So that's not a ratio variable. All right, let's practice a little bit. Temperature. What type of variable is temperature? So think about it. First of all, you want to categorize it as either numeric or non-numeric. You see the numbers on there. Hopefully you've categorized it as numeric. Now second, you want to categorize it as either discrete or continuous. Okay? Now depending on the tool you have to measure temperature, you might go, oh, well, it only has whole numbers on there. But that doesn't mean that you can only measure whole numbers. So if you thought that it was continuous, you're correct, because if you have a better tool, you can measure in between these numbers. Okay? Now the third thing you want to categorize it as is your level of measurement. Is it ordinal? Is it equal interval? Or is it ratio? If you said ratio, think about the zero. Does the zero mean absence of something? No. So if you said equal interval, you are correct. Let's try another one. Place in the Olympics. Now, this is a tricky one. What type of variable do you think it is? Okay, if you said rank, order, or ordinal, you are correct. Blood type. So blood type, whether you have AB, or O. Blood type, what type of variable is that? Think back to the beginning. If you thought nominal, you are correct. Nominal or categorical. If I asked you to line up, think about if I asked you to line up in order by blood type. That would be meaningless. It's impossible unless I say, okay, this blood type here, this one here, and this here. There's no natural order to it. It's just a category, nominal type variable. All right. Let's try another. A score on a statistics exam. So what do you think it is? First, is it nominal or numeric? The scores are numeric. And, well, it would depend on what type of score you give. I could give A's, B's, and C's. Then it wouldn't exactly be numeric, but that would be kind of a rank order. Okay? But the way I give scores, I give you a percentage, how well you did, or a number of points on the exam. So the number of points on your exam, it's numeric. Now, is it discrete or continuous? Here, I would say continuous, because you might get on my exams a 4.5. So you can get a score that's in between. Now, is this rank, equal interval, or a ratio variable? Now you want to ask yourself the question, is there order? So you go down the list. You start off with rank order. Okay? Is there a natural order? Could I say line up in the classroom according to your score on the first statistics exam? Now after you've taken the exam, you'd be able to do that. You could line up by score. So yes, you go, it's at least ordinal. Now, is it equal interval? And if you think about interval, if I know someone's score was 100 and the next one was 99, sure, you know the distance between those two people was 1 point on the exam. So sure, it works as equal interval. Now let's move down to the last step. Is it ratio? Okay. Now remember, the two things to be a ratio variable is that you must have a true zero. So does zero mean absence of something? On this exam, if you score 0, that means you did not get any correct. It represents a true 0. So one more thing you want to think about is, does a ratio make sense? If you score 100 and someone else scores 50, does that mean you scored twice as well as that person, or you got twice as many right as the person who got 50? Yes, it does. It works. The ratio makes sense. So this is a ratio variable. Couple more. Height. Now, you might think that height is a ratio variable. If you think 0 means absence of height, someone 6 feet tall is twice as tall as 3 feet, but could you also measure height as short and tall, or short and medium and tall? Sure, that works. You can measure height short, medium, tall, and then you no longer have a ratio variable. Now you have a variable that has some natural order, so it's a rank order variable or an ordinal variable. So this is why we call these not only variable types, but levels of measurements, because depending on how you measure the variable, it could be a different type of variable. It could be ratio or it could be ordinal. Okay? Typically, you want to start off with the most detail as possible when you're collecting data. So you'd start off with a ratio variable, exactly how tall are they, and then later you can categorize into an ordinal variable. Let's do just a few more. Ethnicity, what type of variable? If you said nominal, you're correct. Distance to school. If you're online, hopefully you aren't having to travel too much. That's great. Distance to school. What type of variable? Think about it. If you said ratio, you are correct. If the distance is 0, that's a true 0. You are not traveling any distance to school. Either you're taking an online class or you live out on campus and you don't have to travel. 0 is a meaningful unit. And if someone drives 100 miles, someone else 50 miles, the person driving 100 miles is driving twice as the distance of the person driving 50 miles. The ratio makes sense, a ratio variable. How many friends you have? How many friends you have? What type of variable is that? Think about it. It's a count. Now, is this a numeric or nominal variable? It's numeric because it is a number. You could list the number. Now, is it discrete or continuous? Discrete or continuous? Can you have 2.4 friends? That doesn't work. So it is a discrete variable, one of the few discrete variables we've talked about in our numeric variables. Now, is it a ratio variable? Think about this. Does 0 mean you do not have any friends? That works. It's a true 0. If you have 10 friends and then 5 of them get upset with you and go away, do you now have half of the friends that you used to have? Sure. So it is a ratio variable, and it's also discrete. Hopefully, these variables are making sense to you. These different types of variables. Get some practice with this, because you are going to need to know what types of variables you're working with later in this class in order to determine which statistical tests to run. Just like you could take an average of gender. Okay? You could label men 1 and women 2, and then add them all up and divide and take an average of those. But does that make any sense? No, it doesn't, because you don't use averages or means for non-numeric data. Same thing with ethnicity. You could label Caucasian 1, Latin American 2, African American 3, give them all numbers, and then take an average. But does it make sense to say the ethnicity of this class is 4.6? It has no meaning. The same way that doesn't make sense, you could take a computer software and input information and run a statistical test, and it'll give you the output. But unless you understand what types of variables you're working with and you know which tests are appropriate for those variables, it's just nonsense. So practice your variables, come up with your own examples, get used to this because this is very important. A lot of people struggle with this concept, and you're going to need to understand these very clearly when we move on to learning the statistical analyses. So just to review, in this lecture we covered branches of statistics, descriptive and inferential, and variable types. And next time we will cover summarizing data with graphs and tables, distributions, and misleading graphs. Thank you, and see you next time.